Welcome to this explainer. Are you ready for a journey to the absolute edge of everything? Because today, we're tackling one of the most mind-bending concepts in astrophysics. We're going on a cosmic quest to understand the furthest reaches of space and figure out what exactly happens at the very edge of our universe. Get ready, because we are heading to the extreme limits of human knowledge. Okay, let's dive right into this. Where is the limit of the universe's expansion? It's really the ultimate mystery. We live our daily lives entirely surrounded by boundaries, right? Walls, borders, oceans. But man, when we look up at the night sky, we are forced to ask, where does it all stop? Is there a physical wall out there somewhere? Or does the cosmos literally just keep going? Well, let's unpack our source material to find out. So our first stop is Section 1, the mystery of the universe's edge, entering the unknown regions. Our source text points out an incredibly frustrating reality for astronomers here. Making accurate calculations way out there is notoriously difficult. Think of it kind of like trying to get a contractor to give you an accurate estimate for building a house, but the house is unimaginably huge, it's constantly changing size, and oh yeah, it's completely invisible to the naked eye. Gathering precise, concrete data in spaces this expansive is an extreme challenge that absolutely tests the absolute limits of our mathematics. Which brings us to Section 2, light years and speed, measuring the immeasurable. To even begin to grasp the scale we're dealing with here, we really have to talk about Alok Varshe, or the light year. Now, you might be wondering, is that time? It has the word year in it, right? Actually, no. It's an absolutely crucial measurement of astronomical distance. It is simply the distance that light travels in one Earth year. The source material highlights that to calculate varying values and map the cosmic materials scattered across the universe, astronomers have to rely on the light year as the ultimate measuring stick. Honestly, without it, our brains just simply couldn't comprehend the math. Okay, I have to share a pretty hilarious moment from our source text's auto-generated transcription. It spit out the phrase "aluk kaveg." Literally translated, that means the speed of potatoes. Obviously, we don't have potatoes rocketing across the cosmos, setting the ultimate galactic speed limit. This was just a quirky phonetic translation error for Alok Vej, which correctly translates to the speed of light. But jokes aside, it's this undeniable constant speed of light, and for sure not flying potatoes, that serves as the fundamental backbone for literally all of our cosmic calculations. Moving right along to Section 3, various models of the universe, cakes, cups, and the cosmos. Now, what's really interesting about this part of the explainer is how to visualize something so incomprehensibly massive. Our source actually contrasts two really peculiar shapes, the cake model and the cup model. Just think about it for a second. A cake might suggest layers of cosmic structures, right? Sort of expanding outward from a center. While a cup might imply a universe with a defined rim or maybe a specific, contained geometry. By bringing these super abstract, dense mathematical concepts down to everyday objects like cakes and cups, scientists give us a much more grounded, tangible visual to wrap our heads around. And this theoretical modeling builds directly into how we actually observe things. Exploring this stuff absolutely requires practical experiments. And I think this shows the deeply human element of our cosmic exploration. We could sit around and theorize about cup models and cake models all day long. But ultimately, human observers have to rely on practical experiments and highly advanced machines to capture ancient light. We use these precise machines to measure these seemingly boundless, infinite regions, which just proves that our quest to map the universe requires immense, totally groundbreaking technological innovation on our part. And that leads us right into our final section, Search for Infinity, approaching the border. So we are finally guiding our attention toward the ultimate climax of our quest here. The absolute edge, or border, of the universe itself. Why can't we just, fly a probe out there and peek over the side? Well, the hurdles to reaching this border are just immense. First off, there's the vast, continuous expansion of the universe itself. Space isn't just sitting there, the actual fabric of space is stretching. Second, the immense speed that would be required to even attempt to catch up to that expansion is entirely beyond our physical capabilities. And third, the sheer, never-ending scale of it all. Because the universe is in a state of constant accelerating expansion, arriving at a static physical edge is practically impossible. The finish line is literally always sprinting away from you. And this brilliantly illustrates an incredibly profound concept from our source, never and never. The source refers to this infinite space not as a physical brick wall, but as a barrier of never and never. It's a really beautiful, almost poetic way to describe the unending characteristic of the cosmos.
You could travel outward for 1 billion lifetimes, and you will never ever reach a definitive end. The universe simply continues, just an endless expanse of possibility.
So what does this all mean? Which brings us to our final, provocative question for today. Is the edge of the universe just an illusion created by our earthly perspective? I mean, if the cosmos is defined by this unending, joyous expansion, does that mean the true limit is simply infinity itself? We look for walls and borders because, well, that's what we know here on Earth. But out there in the vastness of the cosmos, the only boundary might just be the limit of our own imagination. I really hope this explainer has sparked your curiosity and leaves you eager to keep exploring. Keep looking up and never stop asking the big questions.